In yesterday's lecture, we have discussed about the empirical correlations for the free convection. That is what is meant by Nusselt number, then what is meant by Grashof number, what is meant by Prandtl number, what are the equations for that. Okay. After that, we have discussed about the what are the correlations for the vertical plate and cylinder, if laminar flow is there, if turbulent flow is there. Okay. For the horizontal plate, for the laminar flow, what is the correlation? For the turbulent flow, what is the correlation? For the horizontal cylinder, if laminar flow is there, if turbulent flow is there. So for that, we have discussed about the correlation. After that, we have solved problem related to that. Okay. After that, we have discussed about the combined natural and forced convection. In that, we have discussed about the different correlations, which is useful for the at the same time there is a forced and free convection is there. Okay, and we have solved one problem related to that correlation. Now we have to solve the second problem. Okay, so all of you write down the second problem. Write down second problem. Write down 350 mm long glass plate. 350 mm long glass plate. 350 mm long glass plate is hung vertically. 350 mm long glass plate is hung vertically in air at 24 degrees Celsius. Hung vertically in air at 24 degrees Celsius. 24 degrees Celsius. While its temperature is maintained at 80 degrees Celsius. While its temperature is maintained at 80 degrees Celsius. 80 degrees Celsius. 80 degrees Celsius. Full stop. If the same plate is placed if the same plate is placed in a wind tunnel and if the same plate is placed in a wind tunnel and air is blow over it and air is blow over it at a velocity of 5 meter per second. At a velocity of 5 meter per second. 5 meter per second. 5 meter per second. Find the average heat transfer coefficient. Find the average heat transfer coefficient for natural and forced convection. Find the average heat transfer coefficient for natural and forced convection. Natural and forced convection for above mentioned data. For above mentioned data. For above mentioned data. Full stop. Next line. Use the correlation as use Nusselt number, that is Nu is equal to 0.677. Nu is equal to 0.677 into Prandtl raised to 1 by 2. Prandtl raised to 1 by 2. Prandtl raised to 1 by 2 into bracket 0.952 into bracket 0.952 plus Prandtl number bracket raised to minus 1 by 4 bracket raised to minus 1 by 4 into Grashof raised to 1 by 4 into Grashof raised to 1 by 4 into Grashof raised to 1 by 4. Okay, then next equation, Nusselt number is equal to 0.664. Nusselt number is equal to 0.664 Reynolds number raised to 1 by 2, Reynolds number raised to 1 by 2, and Prandtl number raised to 1 by 3, Reynolds number raised to 1 by 2, and Prandtl number raised to 1 by 3, 1 by 3. Okay, so all of you write down the given information from this problem. So length is given, 350 mm long glass plate is there. So L is equal to 350 mm. So we have to convert that mm into meter. So therefore 0.35 meter is hung vertically in air at 24 degrees Celsius. Means air temperature is given, that is TA is equal to 24 degrees Celsius, while its temperature is maintained at 80 degrees Celsius. म्हणजे surface temperature काय असणार आहे? TS is equal to 80 degrees Celsius, and velocity of air is given 5 meter per second. So V is equal to 5 meter per second. 5 meter per second. Okay, so first of all we have to calculate the mean film temperature, that is TMF is equal to TS plus TA by 2. So 80 plus 24 divided by 2, that is nothing but 52 degrees Celsius. And from the property chart we have to write down the properties of air at 52 degrees Celsius. So from the property chart we get the value of thermal conductivity, then kinematic viscosity, then Prandtl number. So all of you write down the properties of air at 52 degrees Celsius. 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 So write down the properties. K is equal to 28.15 into 10 raised to minus 3. K is equal to 28.15 into 10 raised to minus 3 watt per meter degree Celsius. Watt per meter degree Celsius. Then kinematic viscosity nu is equal to 18.41 into 10 raised to minus 6 meter square per second. 18.41 into 10 raised to minus 6 meter square per second. Then Prandtl number is equal to 0.7. Prandtl number is equal to 0.7. Prandtl number is equal to 0.7. Okay, so from this we have to calculate the beta. Beta is equal to, as we know that what is the standard equation of the beta. Beta is equal to 1 upon TMF. So TMF is in degrees Celsius, so we have to convert it into Kelvin. So 1 upon TMF plus 273. So from that we get the value of beta, that is 3.07 into 10 raised to minus 3 per Kelvin, or Kelvin raised to minus 1. Okay, and for the free convection they have given the correlation as a, so write down that correlation. For the free convection, Nusselt number is equal to 0.677, Prandtl number raised to 1 by 2 into bracket 0.952 plus Prandtl number raised to minus 1 by 4 into Grashof number raised to 1 by 4. Okay, so first of all you have to calculate these numbers, Prandtl number, Grashof number. Okay, so what is the equation for the Prandtl number? That is mu Cp by K. Or we have calculated that value from the property chart, that is 0.7. So we have to directly write down Prandtl number is equal to 0.7. Then we have to find out the value of Grashof number. Grashof number is equal to what? G into beta delta T L cube divided by nu square. So G is nothing but 9.81. Beta is nothing but 3.07 into 10 raised to minus 3. Delta T is nothing but 80 minus 24. L is nothing but 0.35 bracket cube divided by nu square, that is 18.41 into 10 raised to minus 6. Okay, so from this calculation we get the value of Grashof number, Grashof number is equal to 2.133 into 10 raised to 8, 2.133 into 10 raised to 8, 2.133 into 10 raised to 8, 2.133 into 10 raised to 8. Okay. Then put this value of Prandtl number and Grashof number into that correlation and find out the value of Nusselt number. Okay. So Nusselt number is equal to 0.67 into bracket 0.7 raised to 1 by 2 into bracket 0.952 plus 0.7 raised to minus 1 by 4 into 2.133 into 10 raised to 8 raised to 1 by 4. So from this calculation, we get the value of Nusselt number is equal to 60.378. Okay. What is the value of Nusselt number? 60.378. 60.378. Okay. And as we know that what is the equation for the Nusselt number? That is HL by K. So HL by K is equal to 60.378. So from that we get the value of H. H is equal to 4.856 watt per meter square degree Celsius. H is equal to 4.856 watt per meter square degree Celsius. Okay, so we get the value of pH, that is 4.856 watt per meter square degree Celsius. So this is the heat transfer coefficient for the free convection. Now we have to find out the value of heat transfer coefficient for the forced convection. So write down that relation. Nusselt number is equal to 0.664 RA raised to 1 by 2 Prandtl raised to 1 by 3 RA raised to 1 by 2 Prandtl raised to 1 by 3. So first of all, we have to calculate the value of Reynolds number. So Reynolds number is equal to rho VL divided by mu. 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 Okay, so from that property table, I have not written the value of density. So we have to take the value from the property chart. Rho into velocity is given, that is 5 meter per second. Length is given 0.35 divided by mu. Okay, so we have to take the value of rho and mu. Our mu by rho is nothing but kinematic viscosity, and kinematic viscosity is given. So Reynolds number is nothing but what is the another equation for Reynolds number? V into L divided by nu. Okay, V into L divided by nu. So from that equation, we have to calculate the value of Reynolds number, and that value becomes 9.505 into 10 raised to 4. Okay, so all of you write down the Reynolds number is equal to 9.505 into 10 raised to 4. 9.505 into 10 raised to 4. Okay, then put this value of Reynolds number. Already we have calculated the value of Prandtl number into this equation and find out the value of Nusselt number. Okay, so put this value into the correlation. Nusselt number is equal to 0.664 into 9.505 into 10 raised to 4 raised to 1 by 2 into 0.7 raised to 1 by 3. And Nusselt number is equal to HL by K. So from this we get the value of H, that is 14.62 watt per meter square degree Celsius. Watt per meter square degree Celsius. Watt per meter square degree Celsius. Okay. So here we have completed that part, that is correlations for the forced convection, natural convection, and combined the forced and free convection, and we have solved the problems related to that. Okay. Now we have to discuss the next point, that is dimensional analysis. Okay. So what is meant by dimensional analysis? Dimensional analysis is nothing but it is a mathematical technique. Dimensional analysis म्हणजे काय असणार, एक mathematical technique आहे. By using that we have to study these dimensions for solving डिफरंट इंजिनिअरिंग प्रॉब्लेम्स. जे काही आपल्याला इंजिनिअरिंग प्रॉब्लेम्स आहेत ते सॉल्व्ह करण्यासाठी आपण काय करणार आहे, डायमेन्शनल अनालिसिस ह्या मॅथमॅटिकल टेक्निकचा यूज करणार आहे. ओके, सो डायमेन्शनल अनालिसिस हेल्प्स इन determining a systematic arrangement of the variables in the physical relationship, combining dimensional variables to form a non-dimensional parameters. जे काही वेगवेगळे पॅरामीटर्स आहेत त्याच्या डायमेन्शन्स वरून आपण काय करणार आहे, एक रिलेशन फाइंड आउट करणार आहे. and we have converted that relation into combining dimensional variables to form non-dimensional parameters. Okay, so all of you write down the new heading. Write down new heading, dimensional analysis. Write down the new heading, dimensional analysis. Dimensional analysis. Okay, so write down what is the meaning of dimensional analysis. Write down, dimensional analysis is a mathematical technique. Dimensional analysis is a mathematical technique. Dimensional analysis is a mathematical technique which makes use of the mathematical technique which makes use of the study of the dimensions, which makes use of the study of the dimensions for solving several engineering problems, for solving several engineering problems, solving several engineering problems, solving several engineering problems, solving several engineering problems, full stop. Next para, dimensional analysis helps in dimensional analysis helps in dimensional analysis helps in determining a systematic arrangement. Dimensional analysis helps in determining a systematic arrangement of the variables, systematic arrangement of the variables in the physical relationship, in the physical relationship, in the physical relationship, combining dimensional variables, combining dimensional variables, combining dimensional variables to form non-dimensional parameters, to form non-dimensional parameters. Write down the use of dimensional analysis. Write down use of dimensional analysis. What is the use of dimensional analysis? To derive the equations, to derive rational formula for a flow phenomenon, present experimental results in systematic manner, to test the dimensional homogeneity of any equation of fluid motion. Okay, so this is the use of the dimensional analysis. So write down the one by one. First, to test the dimensional homogeneity, to test the dimensional homogeneity of any equation of fluid motion, of any equation of fluid motion of any equation of fluid motion of any equation of fluid motion full stop to test the dimensional homogeneity of any equation of fluid motion. Then second to derive rational formulae for to derive to derive rational formulae for to derive rational formulae for a flow phenomenon to derive rational formulae for a flow phenomenon to derive rational formulae for a flow phenomenon a flow phenomenon. Then write on third use to derive equations to derive equations to derive equations to derive equations to derive equations. Then fourth, present experimental results in a systematic manner present experimental results in a systematic manner present experimental results in a systematic manner. Okay, then write down the new heading as a dimensions. In that we have to discuss about the what are the fundamental quantities, what is meant by derived quantities, what is meant by dimension, what is meant by dimensional homogeneity, what are the applications, what are the dimensions of the different quantities. Okay, so basically there are two types of quantities are there, fundamental quantities and derived quantities. So what is meant by fundamental quantity? The quantity which does not depend upon the other quantity. जी क्वांटिटी दुसऱ्या क्वांटिटीवर डिपेंड नाही तर त्या क्वांटिटीला काय म्हटलं जातंय फंडामेंटल क्वांटिटीज किंवा प्रायमरी क्वांटिटीज. म्हणजे कुठले कुठले आहेत, मास आहे, लेंथ आहे, टाइम आहे, टेम्परेचर आहे, एटसेट्रा. ओके, दीज आर दी fundamental quantity because these quantities are not depends upon the other quantities. These quantities are not depends upon the other quantities. Then what about the derived quantity or secondary quantities? The quantity which are expressed in forms of the fundamental quantity. म्हणजे ज्या क्वांटिटी फंडामेंटल क्वांटिटीवर डिपेंड आहेत that is nothing but secondary quantities or derived quantities. Okay, so velocity is depending upon the mass and then time. Okay, so area is depending upon the length. Okay, so in that manner these secondary quantities are depends upon the primary quantities. Okay, so all of you write down the definition of the fundamental or primary quantities. Write down fundamental or primary quantities, fundamental oblique primary quantities, fundamental oblique primary quantities. So write down the definition of that fundamental oblique primary quantities. Write down the definition. The quantity which does not depends upon 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 the other quantities, the quantity which does not depends upon the other quantities, does not depends upon the other quantities, does not depends upon the other quantities. Write down the fundamental quantities. Examples are mass, length, time, temperature, etc. Mass, length, time, temperature, etc. Mass, length, time, temperature, etc. The quantity which does not depend upon the other quantities, that is mass, length, time, temperature, etc. Okay, then write down the second derived oblique secondary quantities, derived oblique secondary quantities, derived oblique secondary quantities. derived oblique secondary quantities. Run down the definition of that. The quantity which are expressed, the quantity which are expressed, the quantity which are expressed in terms of the fundamental quantities, the quantity which are expressed in terms of the fundamental quantities, the quantity which are expressed in terms of the fundamental quantities, in terms of the fundamental quantities are called derived quantities, are called derived quantities, are called derived quantities. Example, write down the examples for the secondary quantities, that is velocity, comma, area, acceleration, etc. Velocity, comma, area, acceleration, etc. Okay, this is nothing but secondary quantity or derived quantity. Then write down the definition of the dimension. Dimension, dimension. So what is meant by dimension? The various physical quantities are expressed in terms of fundamental quantities is called dimensions. Write down the definition of the dimension. Definition of the dimension. The various physical quantities, the various physical quantities expressed in terms of, the various physical quantities expressed in terms of, expressed in terms of fundamental quantities, in terms of fundamental quantities is called dimension, is called dimension, is called dimension, is called dimension, is called dimension. Okay, then write down the next, dimensional homogeneity. Okay, so what is meant by dimensional homogeneity? The expression is said to be dimensional homogeneous when the dimension of left hand side is equal to the dimension of the right hand side. दोन्ही साइडचे जर dimension same असतील, at that time we said that two equations are dimensionally homogeneous to each other. Okay, so write down dimensional homogeneity. Dimensional homogeneity. The expression is said to be, the expression is said to be dimensional homogeneous. The expression is said to be dimensional homogeneous, dimensional homogeneous when the dimension of, when the dimension of left hand side is equal to the, when the dimension of left hand side is equal to the dimension of right hand side, when the dimension of left hand side is equal to the dimension of right hand side, dimension of right hand side, full stop. Next line. In a dimensionally homogeneous equation, in a dimensional homogeneous equation, in a dimensionally homogeneous equation, only quantities having, only quantities having, only quantities having the same dimensions, quantities having same dimensions can be added, subtracted or equated, can be added, can be added, oblique, sorry, comma, subtracted or equated, or equated. Okay, so this is nothing but dimensional homogeneity. Then write down the applications of this dimensional homogeneity: to determine the dimensions of the physical quantity, to check the equation is dimensionally homogeneous, or to convert units from one system to the another system. So these are the applications of this dimensional homogeneity. Write down applications or dimensions, applications of the dimensions. Write down first, to determine the dimension of physical quantities. First, to determine the dimension of a physical quantity, Determine the dimension of physical quantity. Dimension of physical quantity. Second, to check the equation is dimensionally homogeneous. Second, to check the equation is dimensionally homogeneous. To check the equation is dimensionally homogeneous. To check the equation is dimensionally homogeneous. Third, to convert units from third to convert units from one system to another system, one system to another system, one system to another system, one system to another system. Okay, then write down the dimensions of the different quantities. Make a one chart, serial number, quantity, symbol, unit and dimensions. Make one chart for this. First column, that is serial number, second quantity, third symbol, fourth unit and fifth dimensions. Okay, in that A part we have to write down the fundamental quantities. A part as a fundamental quantities. Okay, in fundamental quantities we have to write down the dimensions for that. First quantity, that is mass. Symbol of mass is nothing but m, unit is kg and dimension is m. Okay, then second quantity length, symbol is capital L, unit is meter, dimension is L. Then third quantity time, symbol is T, unit is second, dimension is T. Then fourth quantity temperature, symbol is theta, unit is Kelvin, dimension is theta. Okay, so all of you write down the A, that is fundamental quantities. So all of you write down these first four quantities, that is mass, length, time, temperature. Mass, length, time, temperature. Okay, so all of you write down the fundamental quantities. Fundamental quantities. Fundamental quantities. Okay, after completion of fundamental quantities, write down the B, geometric quantities. Geometric quantities, area, volume, write down the B part as a geometric quantities. In that, write down fifth as a area. So what is the symbol of area? That is A. What is the unit? Meter square. Dimension is L square. As we know that how to write the dimension, area is nothing but meter square. So what is the dimension for the meter? That is L. So meter square is nothing but, therefore L square is there. So write down the geometric quantity fifth as a area. Symbol is A. Unit is meter square. Unit is meter square. Unit is meter square and dimension is L square. Dimension is L square. Then write down the for the volume. Write down for the volume. Symbol is V. Unit is meter cube and dimension is L cube. Dimension is L cube. Okay. Then write down the third as a kinematic quantities. Write down all the dimensions. All of you complete this all the dimensions. After completion, I will proceed. Within 5 to 10 minutes, all of you complete these dimensions. That is kinematic quantities. then dynamic quantities, and then thermodynamic quantities. Okay, all of you complete this within 5 to 10 minutes. Okay, dimensions are over. Anyone reply in the chat box? Okay, dynamic quantities. Force is there. What is the unit of symbol for the force? F. Unit is Newton. And what is the dimension? ml t raised to minus 2. Okay, so in that way, all of you complete these dimensions. Okay, in the dynamic quantities, force is there, density is there, specific weight is there, dynamic viscosity, work, energy, and power. Okay, so all of you complete this. Okay, what is the symbol of the density? Rho. Unit is kg per meter cube, and dimension is ml raised to minus 3. For the specific weight, unit is Newton per meter cube. Dimension is ml raised to minus 2 t raised to minus 2. Dynamic viscosity mu kg per meter second. ml raised to minus 1 t raised to minus 1. Then work energy Newton meter or joule. The ml raised to 2 t raised to minus 2. Power, that is watt, ml raised to 2 t raised to minus 3. Okay, then write down the thermodynamic quantities. Thermodynamic quantities, heat. So what is the symbol of the heat? Q or H. Unit is joule. So ml square t raised to minus 2. Then thermal conductivity K. Unit is watt per meter degree Celsius. So dimension is ml t raised to minus 3 theta raised to minus 1. Then specific heat, kilojoule per kg degree Celsius. L square t raised to minus 2 theta raised to minus 1. Okay, then heat transfer coefficient, symbol is H or U, watt per meter square degree Celsius. Dimension is m t raised to minus 3 theta raised to minus 1. Then gas constant R. Dimension, unit is kilojoule per kg degree Celsius, and dimension is L square t raised to minus 2 theta raised to minus 1. Then thermal diffusivity alpha, symbol is alpha. Unit is meter square per second. Dimension is L square t raised to minus 1. तर त्या युनिटवरनं बघा आता थर्मल डिफ्युजिव्हिटी युनिट काय, व्हॉट इज द युनिट ऑफ थर्मल डिफ्युजिव्हिटी? मीटर स्क्वेअर पर सेकंड. मीटर स्क्वेअर म्हणजेच काय लिहू शकतो आपण? एल स्क्वेअर. पर सेकंड आहे म्हणजे काय होणार? टी रेस टू मायनस 1, कारण सेकंडचं डायमेन्शन काय असते? टी असते. So per unit, therefore t raised to minus 1 is there. So in that way, all of you write down the dimensions of all these quantities: fundamental quantities, then geometric quantities, then kinematic quantities, then dynamic quantities, and then thermodynamic quantities. Thermodynamic quantities. Okay, all of you understood what is meant by dimensional analysis, what is the use of dimensional analysis, then what is meant by dimensions, what is meant by fundamental quantities, what is meant by derived quantities, what is meant by dimensional homogeneity, then what are the applications of this. Okay, then we have written the dimensions of the different quantities, that is fundamental quantities, geometric quantities, kinematic quantities, dynamic quantity, and thermodynamic quantity. Okay, so all of you complete the thermodynamic quantities, that is heat, then thermal conductivity. Write down the symbol of each, unit of each, and dimension of the each term. Okay, so all of you write down the thermodynamic properties. Okay, so all of you complete these thermodynamic quantities. Okay, all of you put your roll numbers in the chat box. Okay, sir, stop the recording and leave the meeting.